Hey folks, how's it going? It's Mr. Murray. I'm coming to you today with a video that is meant to basically summarize today's class. I apologize that I couldn't be here, but I hope that this video will address everything that was intended to be discussed in class today. Please see the Google Classroom for any specific information concerning what needs to be turned in. I'll try to narrate that on the side. There is going to be information regarding a lesson deliverable. Okay, that does need to be turned in to the Google Classroom. Of course, if you're watching this just for enrichment and just to recap ideas, you would not need to do the lesson deliverable. All right, so as usual, there's a couple things you're going to need to have. So first of all, you should have received handout 2-1. It is in my room. It is at the front of the room near the smart board on that little table that I have where I keep like my papers that I hand out. All right, hopefully that's been distributed to you. I gave directions about that. And you do need to have a piece of paper so that you can be writing down the do now. That's going to be important. Okay, hopefully on a separate piece of paper. So the goal is for you to spend some time doing this content. And then I'd like, if you have remaining time, you should spend that time doing the Unit 1 review project. On that note, the Unit 1 review project is due on December 1st, 2020. All right, 11:59 p.m. That is when the final project is going to be due. I will be doing office hours today, and those are going to be from 11 to 12 as usual. Please use the Google Classroom to find the office hours, okay? All right. So today's agenda, we're going to be doing a do now activity. I'll have some reminders about the project as I just gave those actually, and we'll be talking about polynomial operations, okay? This is going to be handout 2-1, the first major handout of the second quarter. You can also find it by going to the classroom, navigating to the classwork tab, and going to the binder checklist, okay? The binder checklist, right, is that Google Doc with links to every single handout. All right, let's jump into it. This activity that you're going to see here is going to be showing up on the unit review project. This is very similar to slide number 32. So this example, if you can do this, you're going to find it's really going to help you finish out that project. Okay, so here's what I need you to do, folks. What I want you to do, please pause the video. I want you to attempt to solve this problem. So I'm going to scroll down, write it just like this. Remember, you got 4 steps. First, you're going to want to condense the logs into a single log. So you see there's 2 logs on the left. You're going to use the laws of logs to condense. Second, you're going to exponentiate. Okay, that's when you turn both sides into powers of the same base. Okay, be aware of what base you want to use. 3, okay, gonna set equal to 0. You'll see why. And solve. Okay, step 4, gonna check for extraneous solutions. Okay, remember, extraneous solutions are solutions where if you do step 3, it appears you have the correct answer, but in fact, when you plug it back in, it will not work. So what I want you to do, take a minute, please pause the video, take a couple minutes to try to solve this do now problem. Then when you're ready, you can unpause and see what I got. All right, and again, this is going to be the very first thing, folks. It's going to go in your lesson deliverable. It is very much to your advantage to put this on your lesson deliverable because you're going to find that, again, it's similar to, I believe we said slide number 32. All right, so let's jump into it. First thing we're going to do, we're going to condense these logs. So using the product rule, right, the log of a product, that is to say x times x plus 4 is equal to the sum of logs, right? If I was going to expand this out, because it's x times x plus 4, that would expand into the sum that you see there. All right, to simplify that, I'm going to distribute the x inside the parentheses. You are allowed to do it because it's inside of the logarithms parentheses. So you're just simplifying. Okay. So exponentiation done, rather condensation done. The condensing has happened. Now we need to exponentiate. So I'm going to raise the left-hand side. It's going to become a power of 2. And the right-hand side is going to become a power of 2. And that is because this is the method of exponentiation. But what that does is an exponent of 2 cancels out a logarithm of 2, leaving us with x squared plus 4x equals 32. Next thing we're going to do, and so that completes exponentiation. Next thing we're going to do, we're going to make it equal to 0. And the reason you make it equal to 0 is because we remember that this is a quadratic. Okay, so hopefully by this point, what we've learned is to solve a quadratic, you first make it equal to 0. And then there's a few strategies you could use. Technically, in the blue step, you could have used the method of completing the square. Typically, we learn that we want to try with factoring first. So we want to see if we can factor this, because what we know is if we can turn it into something times something, right? We know that if two numbers multiply to get 0, one of them has to be 0. So I've got x and x, and then it turns out I want x plus 8 and x minus 4. Okay, and the reason I want x plus 8 and x minus 4, because if you take 8 times -4, you get -32. If you take 8 plus -4, you get +4. Last but not least, you want to find the solutions. The proposed solutions are +8, or -8 rather, and +4. And then we want to think about how do those factor into the solution or the original equation. So if we come to the equation, one thing you have to remember is that when you multiply 2 over and over and over and over again, it will always be a positive number, because a positive times a positive is a positive. And when you divide by it, a positive divided by a positive is also positive. So you can't get 0 and you can't get negatives. So for that reason, -8, when you plug it in, will not work. So therefore, x equals 4. My apologies there. Oop, oop, oop. Try that one more time. X equals 4 is the only solution. Okay? It's the only one that when you ultimately plug it in is going to make both sides of the equation equal. Okay, we can verify that. Log base 2 of 4 is equal to 2, because 2 squared is 4. And then if I do log base 2 of 8 is 3, because 2 cubed is 8, and 2 plus 3 is 5. So 4 checks, okay? So the only solution you should get is 4. Now, a key principle to ensuring the correct answer is you must eliminate any extraneous solutions. If you said -8 was a solution, you would not be getting full credit, because you're saying something is a solution rather, that is not actually a solution. So you do need to eliminate extraneous solutions. Again, those are generally going to happen when you have 2 solutions, and especially if I had only solved, for example, if this one wasn't here we go again. If this one wasn't here, right, and it was just log base 2 of x equals 5, right? Remember, that would have one solution. If I covered up the other stuff, this would have one solution. So individually, they have one solution, but when you combine them, they have, like this, you create something with 2 solutions. So that's where the extraneous tends to pop up. All right, so please make sure you did understand what we did here. This does need to go onto your lesson deliverable. And when you are ready to move on, we can go ahead and continue in the video, and I'll move on to the meat of today's lesson. Okay, so previously I introduced this idea. We're going into a brand new unit and a brand new term. And this unit is going to be on polynomials. Now, the good thing is if you struggle with polynomials or with stuff related to logs and exponentials, that's actually okay, because what we're going to do is not very closely related to logs and exponentials. So there is some ideas, these ideas around maybe the properties of exponents. But really outside of that, you're going to see that if you struggle with that stuff, that's okay. It's a new opportunity to really crush it. So important terminology. So we tend to order polynomials from the biggest power of x to the smallest power of x. The biggest comes first, the smallest comes last. This is what we call standard form, okay? Is where it's arranged biggest to smallest power. Now, some interesting stuff to know. The leading coefficient leads the way. It's the coefficient in front of the biggest power of x, and the degree is whatever that largest power of x is, okay? Assuming that that leading coefficient is not 0, otherwise it would not be visible. So it's the biggest power of x. I sometimes say you can see. All right, throughout high school, you learned about, so far, a couple different types. You learned about linear and quadratic. I'm not sure whether you all learned about cubic last year, but that's something that we'll be taking a look at as we go further. The term rather, comes from the biggest power of x. So linear, the biggest power of x is 1, and the graph looks like a line. Quadratic, the biggest power of x is 2, and the graph looks like a parabola. And cubic, the biggest power of x is 3. And what we'll learn, hopefully by the end of the unit, is the graph looks something like that. And there are some factors, right? You could have a downwards facing line, you could have an upside down U, and actually you could even have a cubic function facing the opposite way. And again, that's some stuff we'll discuss more this year. All right, so at this point, we do need to transition, and we do need to make sure we have 2, 1 sitting in front of us. This worksheet I'm going to fill in as part of the video. I'm not going to do the whole thing today. We'll only go up to so much of it, but it is important that you do cover what is covered in the video today, okay? So to get started, we're going to talk about some terminology, some vocabulary, okay? So at the top, you should see the words mono, bi, tri, and poly. And these are just discussing certain types of nomials, right? So we have a monomial, and a monomial is when you have only one term, such as 3x squared. Oh, here we go again. All right. A binomial is when you have a couple terms put together. So for example, x plus 8, as seen in the do now. A trinomial is when you have 3 terms, x squared plus 4x minus 32. And a polynomial is kind of like a catch-all for any scenario in which you have one or more terms or monomials. So a polynomial is a combination of monomials that has a so-called standard form that looks like this: an x to the n, an to minus 1, x to the n minus 1, and so on, where the numbers that are in front, remember you might know we call these the coefficients, right? And so each a value or coefficient is supposed to be a real number. And we generally say that the leading coefficient is not equal to 0, because if it was, we could get rid of it, and then we could just rewrite it starting at the next power of x. Okay, so it's just kind of like a definition, and that's kind of what you need to know there. What we're going to do is we're actually going to start by talking about some arithmetic. So we're going to do some addition, some subtraction, and also we are going to be doing some multiplication. Okay, so we'll all have that all in there. All right, so the first thing we're going to talk about is adding polynomials, and I'm going to be very clever, and we don't want probably one of those lines. So let's see if I can cut off that, make it a little bit, no arrows on there, and let's try that again. All right, take 2. There we go. So I'm going to cut it kind of halfway down the middle, and I'm going to show you a couple different strategies for doing each one. So for adding, all right, so adding and subtracting is more or less combining like terms. There are a couple tricks to it, and we'll talk about that. So in method 1, what I'm going to do is I'm going to start by rewriting these, remember, in standard form. So I'm going to go biggest power of x to smallest. So the first thing we're going to do, we're going to rewrite this 6x to the 4th minus 18x cubed plus 10x minus 2. Okay, and the second one I will keep in parentheses, minus 7x to the 4th plus 2x cubed. Come on now. Come on now. What's going on with my pen here? For some reason, my pen decides it wants to work when it wants to work, not when I want it to work. Gotta love technology. All right. Let's go, pen. All right, so I guess again, my pen says, hey, you know, I'm gonna work when I wanna work, not when Mr. Murray wants me to work. That's why we always love technology, folks, right? All right, so I got negative 7x to the 4th. I've got 2x cubed. I've got x, and I've got 5, okay? And so now what I'm gonna do is I'm gonna use what I call the column method. So the column method works. I start by writing them in columns. And if you've ever done arithmetic with numbers, then you've seen the column method before. Okay, 10x minus 2. And now I'm going to write a plus, and I'm going to circle the plus to remind myself that it means I'm doing addition. It doesn't mean that's not going with any of the actual terms. It's reminding me what I'm doing with these two polynomials. All right, so now I'm going to add down the columns. Just like if you were doing arithmetic, you'd add down the columns. The good news here is that you're not going to carry over. So sometimes when you go over, right, you got to carry a 1 or carry a 2, so to speak. So we're not going to do that. So 6 plus negative 7, that's negative 1 or negative x to the 4th. Negative 18 plus 2, that's negative 16x cubed. 10 plus 1, that is 11x. Negative 2 plus 5, that is a positive 3. And that's really all you do for this kind of collection of your like terms. Okay, so again, I set it up very meticulously in the columns, and I use that to combine my like terms. All right, of course, feel free to rewind anytime, but do make sure that if I'm writing this, it's also being written down on your copy of 2-1. All right, the other method I'm going to use is I'm going to just kind of use like different kinds of shapes to kind of really identify those like terms. It's just another way of doing it. You don't have to if you don't want to use the column method. All right, here I go. So I'm going to circle. Here's my x cubed. So I'm going to, and usually you start by doing a careful examination to find your biggest power of x. Okay, in this case, it's x cubed. So I've got plus 6x cubed plus negative 7x cubed. So I'm going to combine one at a time. That combines as negative 1. Now I'm going to do the next power of x. I'm going to box it. So I know that these boxes represent like terms, but they're not like terms with the purple circles. So they're like terms with each other, but not with, right, these first terms. So negative 7 plus 12, that is 5. And remember, we're only really focusing on the numbers, right? Once we know the powers of x are the same. All right, next thing we're going to do, I'm going to put these in diamonds. So 12x plus 6x. And then last but certainly not least, I just want to make sure we know it's a minus. I'm going to triangle that, negative 2 plus negative 6, negative 8. Okay, so what you're just doing here, and I believe I made it, I might, unless that was, yep, negative 2 plus negative 6. And just remember, adding a negative is the same as subtracting a positive. So that's all we're really doing, right? We're combining like terms. So I think that it is good if you can do the columns. It's a good strategy to try to do. And if you can't do the columns, that's all right as well. But you do have to have a way of being able to effectively combine the like terms. Observe that in the final solution, I do put everything in standard form, and that is how I would ask you to do it. If you don't have it in standard form initially, that is fine, but your final answer, you do need to arrange everything back into standard form. All right, subtraction. Subtraction, again, very similar. I'm going to teach you two ways to do it. The main difference is subtraction, as we see here, it does matter the order from left to right. With addition, you get a little bit more freedom in that regard. So what I'm going to do, I am going to go left to right. I'm going to set up my the columns here. So what I'm going to do again, I'm going to write it out. So here you got to be careful. So first, notice that there is no x cubed. So when I write this out, I'm going to do 12 x to the fourth. I'm going to leave a gap. I'm not going to write it because there's no x cubes. I'm going to leave a little gap. Negative 8x squared plus 5x minus plus 19. So I leave that gap. All right, over here, right, there's no x to the fourths. So I'm not going to write anything there. I'm just going to move these over a little bit so I can make the plus sign. So I'm not going to write x to the fourths because there are none. And I just noticed it's not addition, it is subtraction. Okay, so nothing here, minus 18x cubes plus 6x squared minus 9x plus 3. And now I'm going to, and it is a good practice to circle this so you don't get it confused with the negative sign, I'm going to subtract down the columns. So 12x to the fourth minus nothing remains 12x to the fourth. No x cubes minus negative 18, that becomes a positive 18. Negative 8x squared minus positive 6x squared, that becomes negative 14x squared. 5x minus negative 9x, 14x. And then negative 19 rather, minus positive 3, giving us 16. All right, that's that first one. Coming over here onto the right, what we are going to get is we are going to use another strategy. On this strategy, instead of looking at it as subtraction, watch what I'm going to do. I'm going to distribute that negative sign, and I'm going to turn it into addition. So underneath, I'm going to rewrite it as plus, but then here, every sign is going to be flipped. So negative 9 minus 2x squared minus 10x to the fifth. Okay, so basically, this now turns into an addition problem, and we can use one of the strategies described above. I'm going to use the column method. So I'm going to put these each in standard form. And one reason I like the column method is because it actually forces you really most of the time to put it into standard form. Okay, so then that avoids the having to rearrange in the final step. There's no x to the fourth, so you saw I erased and didn't put anything there. 8x cubes, negative 4x squareds, and 19. I notice I should skip the x, but there's no x in either one. All right, here, make sure again you put your plus sign. So I have negative 10 x to the fifth minus 2x squared and negative 9. All right, here we go. So down the columns, negative 5 minus 10, negative 15 x to the fifth, 8 plus 0 remains 8. Negative 4 plus negative 2, that's negative 6. 19 plus negative 9, that is positive 10. Okay, so again, the two strategies for subtracting, using the column method with a careful rearrangement to avoid any concerns over like terms not being correctly combined. And the second method is to turn it into an addition problem, in which case you can use one of the strategies that we've already discussed. All right, so please make sure you understand what I did here. In a moment, we are going to move on and give you guys an opportunity to practice some problems on your own. All right, great, folks. So what I'd like you to do, I'd like you to take a few minutes. I would like you to pause the video, and we have 4 problems here: an addition, a subtraction, and an addition. I want you to take a moment and pause the video. Use whatever valid method you have for solving. Then when you're ready, unpause, and you can see what I got. All right. So what I'm going to do is, this is the addition method. This is the addition, so I'm going to do the columns. Be very careful. You want to do 9x to the 7. Then you want to be very careful. There's no x to the 6th in either, so I'll skip that. No x to the 5th in either. This has an x to the 4th. Okay, an x to the 3rd, an x squared, no x's, and a 4, and let's line that up. So again, make sure you do your plus and circle it to indicate you're adding. Okay, then this 11x cubes, this negative 8x squared, and this 12. All right, so negative 9x to the 7th minus no x to the 7th is this. 17x to the 4th minus no x to the 4th. Negative 2 plus 11, that would be 9 x cubes. Negative 8 and plus 8, those cancel. And 4 plus 12, that would be 16. All right. Similarly, we can look at this one down here. So I'm going to use the change it into addition method. So I'll make this a plus. I'll make this a plus. I'll make this a minus, and then we'll use the columns. So again, looking carefully, I notice I've got negative 8x to the 5th, no x to the 4th, 7x cubes, 20x squareds, and 13x's. Over here, start with your plus to remember we're adding. 2x to the 5th, and then minus 9x squareds. And then we'll make our column. We got our column method here. So negative 8 plus 2, that's negative 6, x to the 5th. 7x cubes, those go untouched. 20 plus negative 9 is 11x squareds. And then you have 13x's because it's 13x minus 0x. All right, here I'm going to do a similar thing. I'm going to do flip this to a positive, flip this to a positive, flip this to a negative, make this a positive. Let's set up our columns. 23x to the 7th minus 9x to the 4th plus 1. Okay, now notice how this has x squareds in it, so I actually am going to move that so we get a better lineup. Okay, so that leaves me with, again, put our plus in here. This is a 9x to the 4th minus 6x squared plus 31. Okay, so adding down the column, I see 23x to the 7th. Negative 9 and 9 are going to cancel. Negative 6x squared and 32. Be careful with the sign. I had someone get negative 32, so be very careful with your signs when you're adding up those things because it does matter. All right, last one, we have negative 121 x to the 12th. Let's set up the columns. No x to the 11th, no x to the 10th. We have 1x to the 9, no x to the 8th, minus 1x to the 7th, no x to the 6th, no x to the 5th, no x to the 4th, no x to the 3rd, 3x squareds, and none of those powers I mentioned are on the right side either, so you don't have to worry about that. And then 15x. So you can see again, descending from biggest power of x to littlest power of x. 12, 9, 7, 2, 1. Okay. Now let's line it up. So this lines up with an x to the 7th. This lines up with a negative 68x squared. And then this is a negative x to the 9th. So let's see what we got. So here we get negative 121. So you just do really systematically. Here they're going to cancel. Here they're going to cancel. You get 3 plus negative 68. That's negative 65. And then 15 taken away, nothing. Right? So it is somewhat complicated, but the idea here is you're just adding by combining like terms. My number one strategy, again, thinking about being organized, trying to put it into standard form off the bat, if that's something that helps you, because it keeps things more organized and helps you find those like terms. Just be very diligent and leave no stone unturned. You do want to make sure that there are no repeating powers. So if I see x to the 12th in my final answer, I don't want to see x to the 12th anywhere else. Because if I do, that means that those in that case, those like terms were not specifically and fully combined. All right, so again, anything you need to make sure you have written down, please do that. Again, some of this may appear as part of your lesson deliverable. All right, and then in a moment, I will move on and begin talking about preview behind multiplication. Okay, so multiplication, there are two methods, and I'm going to talk about the first in this video, and we'll loop back and talk about the second one when we next meet. So method one is called the distribution method, and when we do the distribution, we're just going to do what I call the good old wave check. So make sure you do a wave check. You always want to write these little waves here. Okay, wave check, wave check, wave check. The reason you want to have this visual reminder is because you want to make sure every single term in this first piece gets distributed to every single term in the second. And so it helps you stay organized. This becomes x times 1, which is x. Now remember, with the laws of exponents, because you have the x and the x, the powers add. So you have 1 and 1, which is 2. And then you have x times 2x squared. That is 2x cubed. Now I do the same thing with 2. 2 times 1 is 2. 2 times negative 4x is negative 8x. 2 times 2x squared is 4x squared. And now what I have to do is just combine, just add them up. It just becomes an addition. So let's take a look at the biggest power of x. So we have our 2x cubes. Now we have negative 4x squared and positive 4x squared. Those are going to cancel each other out. Now we have x and negative 8x, which is negative 7x. Okay. And then we have a positive 2. Okay. So please make sure you do understand how I got that. It does require some thought there, but again, we're just using the distribution and combining the like terms. Okay. So just make sure if you have any questions, you just think about that ASAP. Okay. So we have, again, 2x cubes minus 7x plus 2. All right. So now I'm going to do the same thing with the other. Distribute, 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 distribute. All right. So that being said, when we distribute here, we get 6x plus 3x squared minus 21x cubes. And then on the bottom, and I wouldn't worry about the colors. That was for the black ones. And then on the bottom, we get negative 8 minus 4x plus 28x squared. All right, pulling these together, we'll put it in standard form. Our biggest power of x first, negative 21x cubed. These combine for 31x squareds. These combine for positive 2x. And these combine for negative 8. So this is just the method of just taking everything in that first polynomial and distributing each of the terms one at a time to the second polynomial. Now, what we're going to be doing after this is learning another method, as you see on the bottom, called the box. And what the box is going to let us do is do the exact same thing that we did in the distribution, but in a little bit more organized way where it makes sense and it's a little bit more like graphical, it's a little bit more organized. So you have a way of really putting things together. And if it's right, we should get the same answer as we did in method 1. In the end, you're allowed to use whichever method you want as long as you can arrive at a mathematically correct answer in a way that is mathematically valid. But that about wraps it up for this video. Please make sure you are checking your classroom for what needs to be in the lesson deliverable, and you are able to get that all submitted. I will leave this video up for the time being for any of you who may need another explanation. Thank you very much for watching, and have a wonderful day.